Welcome to the Demonstrating Implementation Excellence stream of SNOMED CT Expo 2023. My name is Nick Egerhaus, and I'm the Global Vendor Engagement Lead and Customer Relations Executive for the Middle East and Africa at SNOMED International. I'll be moderating today's session. All questions will be answered at the conclusion of this presentation. Online attendees, please use the Q&A button to type your questions to the presenter. And on-site attendees, please use the microphone provided in the room. I'm now pleased to introduce Heather Grain from the eHealth Education, who will be presenting SNOMED CT, the team player. Heather, please go ahead.
Thank you very much. And it's really great to be here today and to see all the faces and to hear all the activity that's been going on. It's exciting. So I'm going to be talking about SNOMED as a team player. So I'm not talking just about terminology in just a terminology environment, because digital health isn't just terminology. It's data elements, it's messaging, it's a whole range of standards that have to work together. And I've been doing some work with implementation and looking at how we can use concept representation, the broadest term, that isn't just terminology, that's about how we define the data elements and the models, and how that information model work operates with terminology. Looking at how we can work the information models together with the terminology to reduce our data errors, improve our data quality, improve the meaning and comparability of our data, and to reduce the data management and governance overloads that we all share. I'll be reporting largely on a couple of projects that have occurred in Australia. And what they've highlighted is the old view, I'm going to call it, where it's like we want one code, and if you'll forgive me, one code to rule them all can bind us in the darkness. We don't want to go that way. But it is the way we have always thought historically. People want one code to represent everything. That's not doing ourselves a favor. It's resulting in really big data sets, with thousands of options that make the user interface more difficult. It leads to local variations. We do need different granularities locally, but we need to have a consistent approach. We need to be able to do queries, yes, using terminology services, but if you're a little organization doing a small project, working out how to use the terminology service to get data you want can be really difficult. And that's the experience that I'm going to be talking about, and how using the information model with the terminology and integrating both together can make those things easier. So these are projects in both Australia and to a degree in Jamaica as well, some of the experiences we've had there, where we were looking at the Open EHR information model, which has been, it's nearly 20 years old now. We heard all about the cloud knowledge gathering process this morning. It is a cloud sourcing tool that has thousands of clinical and health informatics people contributing to the knowledge base that is held there. And what we have been looking at is how we use that tool and SNOMEDize it to a degree, so having the data element represented by not just an archetype ID, but by a SNOMED code as well, which gives you post-coordination in a way that a lot of systems can handle much more easily than a complex language structure. So we want to try, what we've found is we need to reduce pre-coordination in order to reduce the complexity of data capture and to simplify retrieval. So this is one really simple example, and I know it's a futile kind of example, but it is one of the things that we've found. We've found that people have been implementing SNOMED without really thinking about what are they doing. Do you need a SNOMED code to represent an APGAR score of 9? Or do you need a field that says the APGAR score at 1 minute was, and then you need a number in the field? So that's a simple, if you like, error I've seen in implementation all around the world. I would not use the SNOMED code for the value. I would use it for the field. It's much more powerful that way, and it's much easier to work with. We did a big clinical research project with a tool called the Air Coder, which is from Synapse Medical Systems. It's an AI product that takes patient details, the context of the data, and the free text from the clinical record and returns. It can return ICD-based codes, but in this case, we were returning SNOMED. And we were looking at orthopedic specialists getting data from all sorts of records, not one system, lots of different systems. And they provided some basic component data, largely the textual stuff, but with also some patient details. And they were just looking at the ankle and the foot conditions. And we had up around about 100,000 entries by the end of the year-long project. But after the first month, before that, they decided that they wanted to use the national reference sets because they thought that would be the best way to go. And I said to them, I don't think that's going to give you what you want. So they tried it. And after a month, they came back to me and said, why are there 158 types of osteoarthritis? We're only looking at the foot and the ankle, and we've got all these codes. That's not what we want. That's not clinically useful. I mean, it's clinically useful in one context, but it's not actually what they were after. So we made some changes and we said, let's look at this detail. So we looked at how were those concepts defined in SNOMED, very similarly looking at the French example we just had. And we looked and we saw, okay, the differentiations within these 150 odd codes were, we found 5 types of osteoarthritis represented. So 5 actual different disease types. We found causative agents. Some were post-traumatic, some were post-infection, some were dysplasias. There were different causative things. There was different spreads of disease, different stages. But the big one was there's a lot of bones in the foot. So we then went and we said, let's look at implementing this by using data fields. So we looked then at the OpenEHR model and how you could represent the problem, the cause, all of those fields existed in that information model. So we selected those fields. We used the SNOMED code that defines that it's a diagnosis or it's a cause or it's, so we used the structure and the codes of SNOMED and we reprocessed the data through the AI. And we found that we got much shorter selection options in each area. We also had a lot more detail if you needed it. So clinicians could say, oh, I just want to say it's the metatarsal, or I want to say it's the distal end of the 5th metatarsal. They could say either. And that was fine. So they could go to the detail they wanted. The capture process, we did use AI, but in those few places that were doing things manually and selecting from lists, the clinicians initially had said, we don't want lots of lists, we don't want lots of fields. They changed their mind as soon as they started using it. They just went, no, this is way easier. So much easier to use. And we also found when we did some research going backwards at looking at what our results were like, that it was actually also more accurate. Because the lists were smaller for the clinicians to choose from, the searching processes were easier. So the issues we found relate to this historical desire for one code. And I think that largely comes from, we're used to, in the past, we used data for reporting purposes, and we didn't want lots and lots of different pieces. But as we moved to atomic health records, with lots of pieces of data in them, to allow that data to be queried properly, to allow clinical decision support, we have different options than we had before. So one code isn't necessarily the route we need anymore. We've found a significant problem in implementations with a lack of skill in the terminology at the site of implementation. You know, we have a lot of skills now in national release centers, but a lot less in our local organizations. And we also have, I think this is historic too, a static view of data. You know, I'm looking at the data at this point in time, whereas in fact, data is a whole supply chain today. So we have to collect it in a way that allows that supply chain to work, whether it's through sending it through a fire message or whether it is through reporting it to a national project. The principle is the same. So we need those common structures, and we need to look at how we can do that. And some of the things we found were we found some gaps in concepts where if you try to pre-coordinate to the level of this research, you would have had to add even more concepts in SNOMED. It just wasn't a practical thing to do. But if you broke it down into its pieces, you could represent the things you needed, because the body parts were all there, the diseases were there, the laterality was there if you wanted it. So you didn't need to go and ask for lots more codes. It was far more usable. So we're looking at leveraging the changes in digital health as they move to more atomic data, and moving to more use of SNOMED in other ways than just a term set, using it to define the data fields. We're doing that using OpenEHR, and I know that that's happening in other places around the world. It's an increasing way to look at things. And for those of you who aren't that familiar with OpenEHR, it's an information model for data in a health record versus data in a message. I shouldn't have said versus, because they're very complementary. They are not competitors, they are absolute partners, and they're part of the team. So if you have your standardized record using standardized concept representations, like using SNOMED well, a lot of the problems that FHIR helps us solve become even easier. So this new approach also needs some new skills, because one of the issues we've always had, I think, has been terminologists have been boiling the oceans trying to solve the world. The information modelers and message people have been trying to solve all the problems of the world. We just have to do it together. And the view I see for the future is what I call the data item supermarket, which is that's what OpenEHR is to me. It's that I can go and pick all the data elements I want to use. They're already defined. I don't have to think about them. They've been clinically verified. So I don't have to spend time working out how to define blood pressure or how to define whatever the data element is. It's probably there. You know, most of the time I've found it is there already. I don't have to do anything other than use it. So I can go and pick my data elements off the supermarket. I can pick my codes and terms that I need to represent what I'm after from the terminology supermarket based upon a use case. That gives me a completely reusable structure that is consistent in its data and its data quality, but specific to the case I'm trying to, the problem I'm trying to solve, or the data I'm trying to share. So we looked, for example, at on the left there is the OpenEHR problem list, and we applied the SNOMED body structure to the structured body site data element there. And we, in this instance, of course, restricted it to things in the foot and the ankle. But they work perfectly together. You know, there was no issue or conflict. It was really simple and straightforward. And the result we had from the users, the clinical users, they sort of went, oh, I can ask all sorts of questions of my data now. I can collect it in free text, but I can then analyze it. I can just say, well, what are all the problems of the fifth metatarsal? I have no idea what they are, but you can at least ask the question. So what this research showed us was a real need for a coordinated approach and a change in attitude, conquering that, one code to rule them all, or one solution to rule them all. It's a coordinated world now, and we have to start working together. We need to conquer that fear of post-coordination, because there are ways to make it simpler. I know lots of people who all just said, oh, it's just too hard. Using the expression language is too hard. Well, I'm not so sure it's too hard, but there are ways to make it simpler. And if you do it with the data elements in conjunction with the terms, that is one way to get over that problem. So we need to start looking for simple solutions. Now, I know that you can only make it as simple as it is, but the terminology doesn't exist alone. And I think that's been part of the issue, that we've been trying to solve everything just with the terminology, and we don't need to do it that way. So we also need to look at developing more coordinated skills, more skills in understanding how these things work together. We need to go beyond our release centers and educate far more broadly in some of these basic things. One of the learnings we had in Jamaica was that if you do integrated training, so you're training in the data modeling, in data specification, as well as terminology, doing it all together in a coordinated way builds a skill set that's really valuable and is more viable often, because people will see more solutions because they have a greater understanding across the whole scope that we're talking about. So we've been working with eHealth Education to provide online just-in-time learning that's supported Jamaica, and in an integrated way, and using people who've been doing the job to build the training, not just going to a university, reading a textbook and the stuff that's published and producing something, actually doing it from real world with lots of practice and exercises and examples. So to me, the answer is simple. We have to be the team players. We have to seek simple solutions where we can, but do that by being open and innovative and prepared to work with the other people in the team. I think I've been hearing that message said in other ways throughout this week, which has made me very excited, because I think the time is clearly right. People are starting to see that this is the way, and I just encourage everybody to take the bull by the horns and go knock the ball out of the park. We can do it. Healthcare can do it, but we must not do it as individual organizations, as individual hospitals, as individual payer groups, as individual software providers. We need vendor independence in our data, and SNOMED, with organizations like OpenEHR and FHIR, are ways to give us that. So let's look at how we can achieve it. Thank you.
Thank you. Heather will now take questions. As a reminder, if you're in the room, please use the microphone to ask your question.
Thank you for a great talk. I'm tempted to slip it into the onboarding process of our own organization. I have two questions, if I may.
Can you speak into the microphone closer, please? Thank you.
Even closer. Okay, like that. So first of all, I've had a similar discussion many times with my colleagues and with people in the field, and losing out because people say, oh, clinicians will not like this. They want a pre-coordinated code. They don't want separate lists and choices. How did you convince them to try it?
Well, it was easy in this case, because we gave them what they asked for, knowing it wouldn't work, knowing it was not going to give them the results they were after. And I think what was different about what we did was that we had clinicians who actually wanted to research their data in depth. They were also a group who did not have the skills nor easy access to a terminology server. So, they're not going to be able to put in and manage complex requests. And so they gave us all the data. We gave them exactly what they wanted. We gave them one code. And it only took a month of them looking at the data to go, this is not going to give us what we want. So I guess I allowed them to fail. But I made sure they failed big, if they asked for, if their text said something really, really specific, then we got that code, it was there for them. SNOMED can do it. SNOMED is not the issue. And I must have said that so many times, this is not a problem with SNOMED, it's a problem with how you use it. And once we changed to the other approach and they could see the data that they were getting back, there was no question. They were fine with it. They did not want 158 different ways of saying osteoarthritis at all, but they did want to know the sorts of osteoarthritis. They did want to know the causative agents, and doing it this way, they found it really easy to just say, well, show me all the trauma-related things. Suddenly they could ask the questions they wanted to ask, and they could start to build decision support based upon atomic data. So yeah, I would recommend think of the worst possible situation where they really shouldn't do it and do a trial so that you get some champions who go, oh yeah, we understand it now. That's not what we need. I wish I had more advice. I know the problem, and I think we see it everywhere because people are used to the old world. And how do we help them see the new world and what it can give them? And that's what these people saw. They saw suddenly they could get what they'd wanted easily. It was no longer a big trauma to analyze their data, and they didn't go and need to get a detailed terminology person because the information model gave them enough that they could just look at the descriptions and go, okay, I know what I've got. This is easy to do.
Great.
So it's only one example.
No, I love it. I do have a second question if no one else wants to
Sure, yeah.
break in. So also being a SNOMED author, I know that modeling and post-coordination aren't as easy as they look. So for instance, if I create a data set for congenital anomalies, and I have one field that says, or anomalies, one field says whether it's congenital or not, and another that specifies the site. Those expressions aren't going to classify below congenital anomaly because we're missing the pathological process attribute. So, but it would of course work better with other data sets if you were able to determine that axial discongenital anomaly of the fifth metatarsal is equivalent to the pre-coordinated concept someone else was using. So how can you mitigate that or achieve that?
I think it's kind of the same problem, but a bit bigger. And again, we've been looking, we had some work we did in Jamaica that looked at issues around, I'll use personal history, for example, where we don't use the personal history codes from SNOMED at all. We have a field called personal history, and we use the same data set you would for any other diseases, which post-coordinated gives you exactly the same value as if you had used the pre-coordinated term. If you look at the the logic and the attributes, but I think that's something that this whole community has to look at and think, how do we want to manage this? If we are working together with a clinical model like OpenEHR, which is the biggest standard of its type out there, if we work with that, how will SNOMED develop? You know, which way will we go? Do we want these things to be, you know, is it a causative agent concept? Is it a, you know, time of occurrence type of thing? I don't know the answer, but I think the simplest solution is to at least start that discussion, you know, of thinking about how do we work consistently with the information models that are standardized and used out there.
I've been thinking myself about this for a while, and I was considering whether the template syntax might offer some solution there. If you could associate a template with your data set, specify which field should be filled in where, that might help, but I have no idea how to associate a template. So anyone who's willing to contribute to that, I'd welcome that.
Keisha, do you want to say something?
Just offer it.
Great.
Thank you.
Yep.
Thank you.
It can be done, I guess, is what I should say there. Yeah.
Sorry about that. No, thank you. We've just run out of time. Thanks so much, Heather. With that, we'll conclude the session. Online delegates can join another session through the event lobby. Thank you very much.